chorionicity is the most important predictor of outcome in twin pregnancies. Therefore, it turns out to be fortuitous that dichorionicity, that is where each twin has its own placental unit, is far and away the most common form of twin placentation. If you are dealing with dichorionic twin placentation, then you are dealing with the same placental pathologies that are seen in singletons, the things that you are very familiar with. Placenta previa, placental abruption, placental insufficiency, placental infarction. They're the same things. Now, most papers and research projects would tend to indicate that these occur more commonly in twin pregnancies, but they're not different from what occur in singletons. Same thing, placenta previa in a twin with dichorionic placentation, and in a singleton, they have the same implications. But in monochorionic placentation, we are dealing with pathologies that are not only different than the pathologies seen in singletons, but they are different than any other individuals on Earth. These are pathologies that are only seen among twins who must share a placenta in the womb. As I said, it's fortunate then that the vast majority of twins each have their own placenta. So in 8 out of 10 twin pregnancies, each has its own placenta, so 8 out of 10 twins are dichorionic. Now, importantly, 7 of these 8 are from dizygotic twins, but 1 of the 8 is from a monozygotic twin. If you look at it from the perspective of monozygotic twins, 1 in 4 are dichorionic. It behooves us to have some idea of the embryology of twin placentation. I consider this very important, therefore I have placed it into this lecture, and I strongly recommend that you make this part of your understanding of the sonographic scanning of twin pregnancies. Now, we're not going to go through an embryology textbook here. We're going to concentrate on one embryologic structure, the blastocyst. This, as you will recall, is the embryologic structure that gets into the endometrial cavity and implants. So it is the blastocyst that implants into the endometrium. It sticks to the endometrial surface and burrows its way in. The blastocyst consists of 2 parts. An outer trophoblastic ring that produces the placenta and the chorionic membrane. And it also has an inner cell mass. The inner cell mass produces everything else that you see: the embryo, the amnion, the yolk sac, the yolk stalk, everything else, connecting stalk, all of that is part of the inner cell mass development. So rule number 1 is that all dizygotic twins are necessarily dichorionic. Why is that? Because in dizygotic placentation, you start with 2 zygotes. They go through their early cellular divisions, and 2 blastocysts reach the endometrial cavity and implant. There are 2 blastocysts, which means there are 2 outer trophoblastic rings, and each trophoblastic ring necessarily produces a placenta. Therefore, there will be 2 placentas. Now, if the 2 blastocysts implant reasonably far apart, then when you scan the patient in the late 1st or 2nd trimester, you will be able to see 2 sonographically visible placentas. However, if they implant close together, let's say both on the anterior wall or both on the posterior wall, then when you scan the patient, you will only be able to see one sonographically visible placenta. Why is that? Because as the placental masses grow, they will meet and fuse, and therefore, when you look at the patient sonographically, there will be only one visible placental mass, even though there are two placentas as units. As you can easily calculate, the odds of same wall implantation versus opposite wall implantation would be about 50-50. And sure enough, the incidence of fused dichorionic placentation is about 50%. How is it that monozygotic twins can develop two placentas? Well, it depends on when that embryo, the single embryo that formed, decides to split and become two different people. If that split occurs before the formation of the blastocyst, that is in the first 4 days after fertilization, then the placentation will be dichorionic. That happens, as I said earlier, in about 1/4 of monozygotic twins. So we have our zygote, which is going along through its early divisions, and then it decides to split. And if it splits before the formation of the blastocyst, that is any time up to and including the morula stage of development, then two blastocysts enter the endometrial cavity. If there are two blastocysts, there will be two trophoblastic rings, and each trophoblastic ring will produce a placenta. So again, excuse the confusion, but the circumstance will be identical to fraternal twins. Now, because the chorion, that is the placenta, develops before the amnion, all of these circumstances, the predominant mechanism of the division where two blastocysts enter the endometrial cavity and implant must also be diamniotic. There is no other opportunity, again, because the chorion develops before the amnion. If that zygote decides to split later than the morula stage of development, in other words, it divides after the formation of the blastocyst, 4 to 8 days, then these fetuses will necessarily share a placenta, and that is going to occur in the vast majority of monozygotic twins, 3/4 of the time. So, if the division occurs after the formation of the blastocyst, then a single blastocyst enters the endometrial cavity and implants. If there is one blastocyst, there is one outer trophoblastic ring, and therefore that one outer trophoblastic ring will produce one placenta. What then is it that divides? Well, the thing that divides is the inner cell mass. And remember, the inner cell mass produces the embryo, so there will be two inner cell masses. We have twins. And the inner cell mass typically will also produce the amnion, so there is two amniotic sacs. So the dominant circumstance for monozygotic twins is to have a single placenta, monochorionic, and two amniotic sacs, diamniotic. In the rare circumstance where the division comes even later, between the 8th and the 13th day, the amnion has already formed. Therefore, these fetuses must share not only a placenta, but an amniotic cavity as well. Now, I know all the math majors in the audience have already calculated that I was up to 100%, so I'm over 100% here. But suffice it to say, 1/4 of monozygotic twins will be dichorionic, 3/4 will be monochorionic, and a very small number of those will be monoamniotic as well. Monoamnionicity produces the potential for this to happen. That is, that the fetuses tie true cord knots. Now, the pathologist was nice enough to loosen the knot here. But the problem is that with these true cord knots, when the fetuses develop sufficient mass, that when they roll and or pull tight on the knot, they can cut off each other's blood supply. This makes this the most dangerous pregnancy known, wherein you have a mother who is perfectly healthy and two perfectly healthy fetuses, and then all of a sudden they're both dead. Now, the incidence of death in monoamnionicity is variously reported, but if you think that it's about half of the time, in other words, 50% of these fetuses will be lost if not accurately diagnosed by you and I, then you have a pretty good idea. So unrecognized monoamniotic, monozygotic twins have a very high risk of death for the fetuses. What is happening here? What are we looking at embryologically when we have monochorionic, monoamniotic? Well, this results when there is division after the formation of the trilaminar embryo. Now remember, the trilaminar embryo is this endoderm, mesoderm, ectoderm guy that we all learned about. And that trilaminar embryo occurs between the single amnion and the yolk sac. So the amnion has already formed, and therefore there is only going to be one amnion. So what is it then that divides? The thing that divides is the trilaminar embryo. So we end up with twins. The embryo divided into two embryos. We have twins, but they must share both an amnion and an amniotic sac and a placenta. In the extremely rare instance where the division occurs after the 13th day, then the embryonic disc will not fully divide. Therefore, the fetuses will share not only a placenta and an amniotic cavity, but they will share body parts. So, we end up in the circumstance where the trilaminar embryo fails to completely divide, and therefore whatever does not divide is shared by the twin fetuses. They are conjoined because of the incomplete division of the trilaminar embryo. Conjoined twins. After formation of the trilaminar embryo, the pregnancy will be both monochorionic and monoamniotic. It may have separate twins or conjoined twins. So all conjoined twins are also monoamniotic. So unlike the circumstance with dizygotic twins, where there is only one possibility, and that is dichorionic, diamniotic, with monozygotic twins, you have numerous possibilities. They can be dichorionic, diamniotic with separate placentas, dichorionic, diamniotic with fused placentas, monochorionic, diamniotic, monochorionic, monoamniotic, and they can also be monochorionic, monoamniotic with fused fetuses. All of those possibilities exist. The good news is that these are staged embryologic events. If fetuses are conjoined, that's the end of the embryologic line. So conjoined fetuses must also be monoamniotic, must also be monochorionic. If you are dichorionic, you must be diamniotic. So again, if you understand the staging of the embryologic events, you can make rational judgments about the status of twin pregnancy.